Hello and welcome. Today, we're diving into the exciting world of handling GET requests in Spring Boot. This is a crucial aspect of building RESTful APIs, where you retrieve data from your server efficiently and effectively. Let's get started. The GET method is used to read or retrieve a resource. When you send a GET request, you're asking the server for data. It's important to note that GET requests should only be used to retrieve data and should not cause any side effects on the server. This ensures that the request is safe and does not alter the state of the resource. Let's get started. Let's create a new project. Open your web browser and follow along as we set things up. Open start.spring.io in your browser. This is where we'll kick off our new Spring Boot project. Once you're on start.spring.io, select the project type as Maven, the language as Java, and choose the latest release version of Spring Boot. For the group ID, enter com.gan.derpun. And for the artifact ID, enter employee service. Set the package name to com.gan.derpun.employee. Feel free to customize these settings as needed. Select the JDK version. For this tutorial, we'll use JDK 21, as we installed it at the start. Choose JDK 21. Next, click on Add Dependencies and add Spring Web. This will include the necessary components for building web applications and RESTful services. Also, add Lombok to the dependencies. Lombok helps reduce boilerplate code by providing useful annotations for common tasks like generating getters, setters, and constructors. Click on the Generate button to download the project. This will provide you with a zip file containing your new Spring Boot project with all the selected configurations and dependencies. Open IntelliJ and import the project. If you're unsure how to import a project, click on the icon to watch a tutorial video for guidance. Now, let's dive into the exciting part, creating our first GET API. First, create a new package named controller. Next, create a new class named DemoController within the controller package. Annotate this class with @RESTController. The @RESTController annotation tells Spring Boot that this class will handle RESTful web service requests. It combines @controller and @responseBody, meaning Spring will automatically convert responses to JSON format and return them to the client. This makes it easier to create RESTful web services. Let's create our first GET API. Spring Boot provides the @request mapping annotation for mapping web requests to specific handler methods. The @request mapping annotation can handle various attributes, allowing you to define multiple aspects of a request mapping. For instance, you can specify the HTTP method, URL pattern, headers, and more. To create a GET API, you need to specify the method attribute of the @request mapping annotation and set its value to request-method.get. As we can see, the request method enum contains multiple HTTP methods such as get, post, put, delete, and more. Each of these methods is used to perform different types of operations in a RESTful API. Next, we need to define the path for our GET API. Add the path attribute with the value hello. This will map GET requests to the /hello endpoint. The @request mapping annotation has an attribute called produces, which tells our REST API what type of data format it will support. This is useful for defining the format of the response. We're designing a simple GET API that returns plain text. Let's add the media type to specify the response format. On your screen, you'll see multiple media type options from different packages. Make sure to select org.springframework.http.mediatype. The produces attribute can accept an array of string values, allowing you to specify multiple media types that your API can produce. Specify the produces value as mediatype.text_plain_value. We've learned how to use the @request mapping annotation for GET requests. Now that we've applied the annotation, we need to write the corresponding code. So, let's go ahead and write the method. Just below the @request mapping annotation, let's create a public method named sayHello that simply returns hello. Now our REST API is ready. Let's start the server to see it in action. Start the application. If you're unsure how to start the application, don't worry. You can refer to the earlier videos in this series where we covered the steps to start a Spring Boot application. Now that our application is running, let's switch over to Postman. Postman will act as our client to send REST calls to our service. This way, we can test our GET API and see the responses. In Postman, you'll find a new button on the left side. Clicking on this will present multiple options like creating a new HTTP request, collection, and more. You can create a collection to organize your APIs and save their curl definitions, so you don't have to type them repeatedly. However, this feature is currently disabled. To enable it, you'll need to log into your Postman account. Select HTTP to create a new request. This will allow us to configure and send our GET request to test our API. Select the Get HTTP method from the drop-down menu. In the URL box, type our REST API URL localhost 8080/hello. Click on the Send button to send the request. As you can see, we received the response hello from our API. This confirms that our GET request was successful and our REST API is working correctly. Great job! Click on the Headers tab of the response in Postman. This will show you the details of the headers returned by our API, providing additional information about the response. In the Headers tab, you can see the content type header showing text/plain. This is exactly what we set in our API using the produces attribute. Additionally, you see charset equals UTF-8, which specifies the character encoding. Other interesting headers include content length. This is 5, which perfectly matches the length of the word hello. Date. This header indicates when the response was generated. These headers give us valuable insights about our response and confirm that our API is functioning correctly. Isn't it great to see everything working as expected? Let's go ahead and stop the server. We used @request mapping with the method attribute to create our GET API. But guess what? There's an even better way. Spring Boot offers the @get mapping annotation, which combines @request mapping and method equals request method to get into a single, more convenient annotation. This makes our code cleaner and more readable. Let's make our code even cleaner and more efficient. Instead of using @request mapping with the method parameter for our GET API, we can use the more convenient @get mapping annotation. This will simplify our code and make it more readable. So, let's replace @request mapping with @get mapping and remove the method parameter. This small change makes our code more concise and focused on GET requests. Start the application again. Now, let's open Postman again. Our application is up and running. Click on the Send button again in Postman. Wow, it's working. We got the expected hello response. Everything is running smoothly with our new @get mapping setup. Look at that. On the right side, you can see the status code 200 OK. We didn't explicitly send the status code. Spring Boot automatically adds 200 OK for successful responses by default. But here's the cool part. We can manage this status code ourselves. Spring Boot provides a way to customize our status codes, giving us more control over our API responses. Isn't that exciting? Let's dive into how we can tailor our status codes to better suit our needs. Spring has an awesome feature called Response Entity that lets us take full control over our responses. With Response Entity, we can customize the status codes, add headers, and include body content. This means we can fine-tune exactly what our API sends back to the client. Ready to make our API even more powerful? Let's dive into how Response Entity can enhance our responses. First things first, let's stop the server. Let's take our API to the next level. Instead of just returning a plain string from our method, we're going to return a response entity, string. Now, we can't just return hello directly from the method. Instead, we'll create a new response entity and pass two parameters. The first parameter is the response body, which is hello, and the second parameter is the HTTP status code. Spring has a handy HTTP status enum that includes almost all the standard status codes. This makes it super easy to set the right status for our responses without needing to remember or type out the actual code numbers. Right now, our API is sending a default status code of 200 OK. For testing purposes, let's change it to 201 created to see how it works. However, keep in mind that for GET APIs, a 200 OK status is typically preferred for a successful response. Let's make this change and observe the difference. Start the application again. Let's fire it up and see how our changes work in action. Now that our application is up and running, let's switch back to Postman. Click on the Send button in Postman to send the request to our updated API. Awesome, we got the response. As you can see, the status code is now 201 created. This shows that our changes are working exactly as planned. Isn't it amazing to see how we can control every aspect of our API? Great job testing it out. Let's switch our API status code back to 200 OK, which is the usual success response for GET requests. This helps keep our API in line with best practices. Let's make that change. According to standards, GET requests typically don't support a body. We've successfully demonstrated how to handle GET requests and customize responses using Spring Boot. Thank you for following along. You've learned how to create a GET API, manage response status codes, and use Response Entity for more control. Great job, and keep exploring the exciting world of Spring Boot APIs. In our next video, we'll cover how to return a JSON response from a GET API. Stay tuned, and don't forget to subscribe for more tutorials.